we are looking into number bases. There are different number bases. The commonest one known generally is base 10 because everybody counts in base 10. When looking mathematically, we have different types. We have base 2, which is generally referred to as binary. Binary, bi meaning 2. We have base 3, base 4, etc., etc. We are considering the numerals in base 2, which could be written in this form: base 2 numerals. In base 2, one, 10, 11, 100, 101. This is 110, 111. This is 1,000. That's numerals in base 2. We are looking quickly into base 5. Numerals in base 5 could be written as these: 1, 2, 3, 4, 10, 11, 12, 13, 14, 20, 21, 22, 23, 24, 30, 31, 32, 33, 34, 40, 41, 42, 43, 44, 100. Looking at this, we realize that we are not to allow the base number to appear. The base number forms the 10. Looking at base 2, you see that nowhere where 2 appears. 2 is the base. Wherever 2 should appear, that should be 1, 0. So it is in all bases. We can generate these going into what we call hexadecimal base. Hexadecimal base is base 16. Base 16. You'll be wondering, how are we going to represent this? Of course, in base 16, we could say something like this: base 16, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. I think E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These alphabets, shown as alphabets here, are really figures. Okay? That gives us the exact decimal base. We can go on, but restricting ourselves to what the syllabus requires, we shall look into the octa base, the base 5. The octa base is base 8, base 5, up to base 2. let's look at how these conversion, how the conversion could be made. We can convert from one base to another. How do we go about that? We can go from the higher base to the lower base, and from the lower base to the higher base. Let's quickly look into one or two examples. Conversion from one base to the other. Let's look at a base 10 number to a base 5. Let's look at 22. Base 10, we normally represent this in this form. How then do we go about it? This is the method. We have 22 to be divided by the base. This is 5. 5 divides 22. That should be what? That should be 4 times. 4. Remainder what? Remainder 2. Okay? Now, 5 dividing 4, that is 0. Remainder what? Remainder 4. So here we consider it this way. 22 base 10 will be equal to 42 base 5. Let's come here and check whether we are right or wrong. Of course, this is 5, 5, 10, 15, 20, 21, 22. That is 42. This is in base 5. That tells you that we can convert base 10 to base 5, or whichever base that we want to do the conversion. Right. Now, what about if we are converting from a given base to base 10? Let's quickly look at that. And we are going to pick from these base 5 whose numerals have been written so that we can easily make a reference. Now, we have 44 base 5. What is its equivalent in base 10? How do we go about this? 44 base 5 could be written like this. This is 40, 410. This is 4 units. So over here we have 4. Our 10 is 5, so 5 raised to power 1 plus 4. How many of what? How many, what is here? What is 4 representing? Unit. And unit could be written as 5 raised to power 0. 5 raised to power 0 is 1. And so 5 raised to power 1 is 5. 4 multiplying 5 will give us what? That is 20. And 4 multiplying 1, that gives us 4. And so we have 20 plus 4, which is 24. This is base 10. Looking at this, we can make reference in our numerals here. So here we have 5, 10, 15, 20, 20, 21, 22, 23, 24. Okay, 24 is our what? Is our 44 base 5, and 24 counting in base 10. So this is how the conversion goes. This is the base numbers being converted. The numerals had been shown how it could be written, and the conversion had been shown. We can go on and on the operation, the subtraction, the addition, the multiplication, and the division in this same base, just as we can operate in base 10. Now, this is about the number bases. We've shown what the number bases are, how the numerals in different bases could be written, and how we can do conversion from the higher base to the lower base and from lower base to the higher base. And I hope this is well understood. Thank you so much.